Okay, so we're up to question 3 on tutorial 8. Let's take a read. Suppose that a market model has two stocks. We have S and S dash. Trading dates 0 and 1. We have a risk-free rate 20% per year, annual compounding. Okay. Suppose the stock price at time 0, £3.75, and then it can take three values. Right, we'll take a look at that in a moment. Probabilities P1, P2, P3. And then we got some alternative situation. So we have S dash, £4.50. Prices could be those. Hope that's not too dark. And the question is this market model viable? Justify your answer. Okay, so let's build some ideas here. So I'm going to try to store the information as vectors. So the vector of the stock reads at time 0, we have a pair of opening values. And then later on, we have a range of potential values which fit into some probability distribution. So let's take a look at that distribution. So we have S1 and S1 dash. Can take some values. I think I'll call them XY. And we want the probability, actually we're given the probability that these vectors are equal to XY. Okay, so the first one, we're given 6 and 7. And the probability is P1. Moving across, we have 4 and 6, P2, and 1 and 2 for P3. Okay, so that's just a summary of the information I'm given. Now some theory. Well, the market model is viable. So what does that actually mean? Well, mathematically, it means there exists a risk-neutral probability Q, which consists of three values because we have three possible outcomes, such that each of the Q's are between 0 and 1, and they all add up to 1. That's the first condition. And if we calculate the expected future value using this probability distribution and then discount it to today, we should get the original opening prices of the stock market. So this is the system we need to solve. Okay, or address. Trying to figure out, is this possible? Okay, so we need to build some equations. So we require the expectation of this vector to be, okay, how am I gonna write this? One plus the risk-free rate, which is just some number, so it's a scalar multiple of this vector. Okay, so what I'm saying is take the initial vector and compound it using the risk-free rate. so risk-free compounding, and this should give the expected value of the vector which contains the outputs in the two different markets. Okay, so from this I want to build some equation, and then I want to solve the equation and see if it fits into our picture. So what equation do we have? The expected returns. Okay, so I need to go through all these probabilities. Let me just think about this. We need Q1 S1 at 1, Q2 S2 at 1 plus Q3 S3 at 1 should be equal to, so I'm just looking at the first component at the moment, so I'm looking at the market with stock S. This should be equal to 1 plus R S0 from the first components. Maybe I should be a bit clearer what I'm doing. We're looking in here. Now in the second component we should have Q1 S1 dash 1, Q2 S2 dash 1, Q3 similarly, all that is equal to 1 plus R times the initial share price for the stock market containing S dash. Anything else we can say that's useful? We need one more equation. Yeah, we can say that the sum of the Q's must be 1. Okay, so we have a system of equations with 3 unknowns. Okay, and our system has 3 equations, so we can solve this. So the system we're interested in is, let's do it. So using those probabilities, we have 6 Q1 plus 4 Q2 plus 1 Q3 is 1.5. 7 Q1 plus 6 Q2 plus 2 Q3 is 5.4, and then the sum condition, which equals 1.0. Okay, and from this we now need to solve and check whether the answer, the values of Q are between 0 and 1. And maybe there's a unique solution, maybe there's infinite solutions, maybe there's no solutions. We need to know about this. Okay, so actually I don't mind which method you use here. Even in an exam, just pick the method that works for you, something you're most familiar with. For me, Cramer's rule is, I think it's the easiest one for me. So that's what I'm going to do. If you want to do Gaussian elimination, then just do it. So for Cramer's rule, I'm going to build the determinant of the coefficients on the left-hand side. Okay, so I'm going to expand across the top row. So I'm going to use 6, 4, and 1. So 6, and then I'm going to do the minor, which is 6 taken away 2. Then the 4, so I need a negative. The minor is 7 taken away 5. And then the 1, the minus 7 take away 6, which is 5. Okay, then I'm going to look at the first row, and I'm going to replace the 6, the 7, and the 1 by the column on the right hand side. This is Cramer's rule. Everything else stays the same. Calculate this determinant. I think I will expand across the top row again. So 4.5, 4 and 1. Which gives 3.8. Got a feeling I should leave that as a fraction. So 19 over 5. Yeah. I think fractions are better. Soon find out. Okay, so the next one, I'm going to replace the column on the right in the middle, in the Q2 column. The other columns are going to stay the same as D. Okay, I'm getting a bit bored of writing those out. That's -1/2. And similarly, we replace the right hand side numbers in the Q3 column. These stay where they are, the D column, which gives 17/10. So when I calculated those, I just expanded across the first row. And what we find is the system. Nothing unusual is going on here. We don't have any singularities. It has a unique solution. And the solution is, so it's dq1 over d. So we have 19/5 divided by 5, which is 19 over 25. Then we have -1/2 divided by 5, which is -10. 17/10 divided by 5, which is 17/50. So the conclusion is there's a unique solution, however, Q2 is less than 0. Hence, Q, which consists of those three probabilities, is not a probability mass. And so there doesn't exist a risk neutral probability measure. Okay, so the conclusion is the market is not viable. And that completes the question. Not much more to say really. It's standard methods. I prefer Cramer's rule. You can use your own. Take a look for those steps. I think that one's quite a nice question. And there's the complete answer.